All right, 10.7, circle area and sector area. So we'll start off with something we know already, the area of a circle. The area of a circle is found by taking pi times the radius squared. So in the first question it says, find the area of a circle with a diameter of 32. Well, if the diameter is 32, that means the radius is just 16. So we know our area is equal to pi times 16 squared. Well, 16 squared would be 256. So our answer could be 256 pi. Or if we want the decimal form of this, we would get 803.84 feet squared. So both of these work. Question 2 says find the area of a circle with a radius of 13. So we're already set up for this one. So area equals pi times 13 squared. 13 squared in this case is going to be 169. So we got 169 pi. Or if we want to multiply this out, we'll get 530.7 inches squared. Question 3, same idea. They give you the diameter. So you know the radius in this case is 24. So find the area. It's pretty simple. Area equals pi times 24 squared. In this case, 24 squared is going to be 576 pi feet squared. Question 4 actually has you working backwards. It says a circle has an area of 250 pi, find its radius. Well, the 250 pi is your area, and we know the area formula is pi times radius squared. So we're just going to solve this backwards to get r. Since there's pi on both sides of the equation, they're going to cancel each other out naturally. So you're left with 250 equals r squared. To undo the 250 and the r squared, you square root, and you're going to get the radius is right around 15.8. In this case, it doesn't give units, so we'll just say units. So a sector of a circle is region bounded by an arc of a circle and two radii of the arc's endpoints. So what we're looking at, in last section we looked at just the length of the edge of the arc here. So length of the arc. Now we're talking about sector area. So it's kind of like we're looking for the area of a piece of pizza out of the entire pizza. So we're just looking for a slice of pizza. The area of a sector of a circle is the product of the ratio, and so it looks very similar to arc length. We're taking the measure of the arc divided by 360, but this time instead of multiplying by circumference, we're multiplying by area of circle. So this is the formula we're going to use to find area of sector. So what is the area of sector GPH? Well, GPH is this section here. So we're going to find the area of this sector. Well, that means we're taking arc measure, so 72, over 360 times area of the circle, which would be pi times 15 squared. So we can simplify 72 over 360. It's just 0.2 in this case. And so 0.2 times pi times, in this case, 225. We can take 0.2 times 225. We're going to get 45 pi. Or if we multiply this out, we get 141.3 centimeters squared for the area of our sector. So this time it wants to know the area of sector RST. Well, that's this region here. Very similar. We're going to take the arc length, or arc measure, sorry, 84 over 360 times the area of the circle, which is pi times 9 squared. Well, 9 squared is 81. We got pi, and then 84 over 360 is right around 0.23. And so in this case, you go ahead and multiply the 0.23 times the 81, and you're going to get your sector area to be 18.63 pi, or right around 58.5 millimeters squared. A circle has a radius of 4 inches. What is the area of the sector bounded by a 45-degree minor arc? So what I want you to do is try this one on your own. see what you come up with, pause the video, and then when you're ready to see the answer, unpause it and see if you got the right answer. So your setup should be 45 over 360 times pi times the radius of 4 squared. In the end, you end up with 2 pi, or 6.28 inches squared. A circle has a diameter of 9 centimeters, which basically tells us the radius is going to be 4.5. What is the area of the sector bounded by a 202 degree major arc? So remember, this case we'll be setting it up 202, 360 equals pi times your radius squared. So go ahead and finish solving this, and then when you're ready to see the answer, unpause the video. So in this case, you should end up with right around 11.36025 pi, or in this case, if you multiply it out, 35.67 centimeters squared for your area of your sector. So this last part talks about taking the area of a sector to find the area of a segment, which is just basically like trying to find the crust of the pizza. So you, instead of finding the whole area of the pizza slice, you're just finding the area of the crust part of that slice. So what is the area of the shaded segment shown at the right? Well, in your case, you don't have a shaded segment, but I can tell you right now, it is this segment here. So in this case, we're going to find the area of the sector first. And then we're going to subtract the area of the triangle that we don't need. So in this case, area of the sector would be 90 over 360 times pi times 4 squared. And then we're going to subtract the area of the triangle. Well, this triangle is a 4 by 4 triangle, so that's 1/2 4 times 4, or 1/2 base times height. So at which point we now have 1/4 times 16 pi minus 1/2 of 16, which would be 8. So 1/4 of 16 pi in this case, we're looking at 12 point, when you multiply it out, 12.56. So that's minus 8 for the triangle area. Should give you an area of the segment in this case of right around 4.56 inches squared. In this case, we can't leave it in terms of pi because the triangle doesn't have its area in terms of pi, so you're kind of bound to get a decimal answer here. Question 2, what is the area of the shaded segment shown at the right? So once again, we're looking at the shaded segment would be this piece here. Similar setup. You're going to have 60 over 360 times pi times 18 squared. So that's the area of your sector minus the area of that triangle there. Well, in this case, to find the area of this triangle, you got to do a little bit of work, and you've got to actually find the height using Pythagorean theorem and things like this. Well, to save time, I'm going to go ahead and give you the height. The height of this actual triangle here is 15.6. So we're looking at finding the area of the segment using that information. So we've got 1/2 base, which in this case, it's actually an equilateral triangle, so it's 18, times the height, which is 15.6. And so now we're going to calculate the area of our sector as well as the area of our triangle, and we're going to subtract the two to find the area of the segment. Well, for the sector, when you take 60 over 360, that's 1/6. 1/6 times 324 times pi should give you right around 54 pi, or if you multiply it out, which we have to in this case, we're going to get 169.56 inches squared. So this is what we want, and we're going to subtract it from, in this case, we can find the area, we're going to subtract from it the area of the triangle. Well, the area of the triangle in this case is 140.31 inches squared. So we're subtracting these two. So our segment here has an area equal to 169.56 minus 140.31, which in this case is 29.25 inches squared.